In this chapter, we will learn how to names and write chemical formula for molecule and compound. So our world is made up of chemical substances, starting from macroscopic matter such as you and I, the human body. Our human body is further made up of cells, and cells are then further consist of proteins, and proteins are further made up of even smaller chemical entity that we call molecules. And molecules are then further made up of atoms. Of the different types of atoms that we see from the periodic table, many of them are not stable by themselves, so therefore they come together to form molecules. And molecule can be elements and compound. And here in chemistry, we are studying matter at the molecular level, so therefore we will learn how to name element and compound. Every chemical substances has a unique chemical formula to it. So basically we call this the law of constant proportion, which basically state that a given compound always have the same proportion of their constituent element. For an example, water is always H2O. Water is not H3O or H1O or any other combination for that matter, but always H2O. If it is H3O, it will be a different chemical substance. And if it is H1O, it will be a different chemical substance as well. So every chemical substance has a unique chemical formula to it. And its proportion will always be the same. So therefore, if we were to have 18 grams of water, that would then decompose into 16 grams of oxygen and 2 grams of hydrogen. And this mass ratio between oxygen and hydrogen would always be the same. So the mass ratio between oxygen and hydrogen in water would be 16 grams of oxygen over 2 grams of hydrogen. So here in this case, we would then see an 8:1 ratio. So this 8:1 ratio right here would always be the same. So despite where it's come from, whether water is found here on Earth or on a different planet, it will always have an 8:1 mass ratio between oxygen to hydrogen. And the reason is a chemical formula is always H2O. So we know that every chemical substance has a unique chemical formula to it. So how do we represent it? A chemical formula can be represented as follows. And here's an example of the generic format of a chemical formula. So here in this case, a chemical formula tells us what types of elements that are present in a substance. And second, what is the relative number of each of the atoms in its substance. So first, a chemical formula indicates the element that is present. And second, it shows the relative number of each of the elements. Show the relative number of each element. So in this example below, the A and E refer to the element A and E that make up the chemical substance, and X and Y show the relative numbers of each of the atoms that are present. So these are the subscript that show the amount of element A and element E that are present in the chemical formula. And when we have different types of elements that make up a chemical formula, we normally list them in a particular order in which it goes as follows. Carbon is listed before phosphorus, phosphorus before nitrogen, and so on. So we basically list them according in somewhat follow the order from the periodic table. So metal are listed first before non-metal. And when we have different nonmetal, the different nonmetal are arranged as follows. And it basically also follows the order of the electronegative value, in which the less electronegative atoms are listed first. So that's how we will be listing the different atoms when writing chemical formula. And chemical formula can be further split up or divided into 3 different types of chemical formula. And each of the different types of chemical formula would convey and tell us different amount of information. For an example, the empirical formula. What is the empirical formula? Then this is the simplest types of chemical formula in which they show us the types of elements present that make up the substance, and it also shows us the relative number of each of the elements. Now, it shows us the different types of elements present in the lowest ratio, but not the actual number. So let's write a few things about chemical formula. This is the simplest types of chemical formula, and it shows the elements that are present. And it shows the relative number of each element in lowest ratio. But not the actual number. Of each atom, and simply show us the, again, lowest ratio of each of the elements in numerical value. And second, the molecular formula. The molecular formula basically convey every types of information that the empirical formula would show, but in addition, extra information, in which the molecular formula actually shows us the actual number of each atom, not just the ratio, but then show the actual number of each element in a substance. However, the molecular formula still do not show us a whole lot of information about a chemical substance because it do not show how the atoms are connected. So, do not show how the atoms are connected. So if we were given the molecular formula of a substance, we wouldn't be able to figure out what is the exact identity of the substance because we don't know how the atom may be connected together. And finally, the structure formula. These types of formula right here convey the most amount of information, in which it now shows us how exactly the atoms are connected. So this shows the most information. And it shows how the atoms are actually connected. Show the connectivity of the atoms. And a lot of time, we refer to these types of chemical formula right here as the Lewis structure. The Lewis structure is a type of structure formula because in the Lewis structure, it shows how the atoms are connected. For an example, here is a molecule, and this is basically acetic acid. And what we've been shown in here is the Lewis structure of acetic acid, and we see that it consists of 2 carbon, 4 hydrogen, and 2 oxygen. And in this case right here, we know how the atoms are bonded together. For example, this carbon is double bonded to this oxygen, and this carbon is single bonded to this oxygen, and this oxygen is then bonded to the hydrogen. So here in this case, because we know the connectivity of the atom, these types of structure are then called the Lewis structure, and this is an example of a structural formula. So here in this case, if we were to write the molecular formula for this, it would then equal to C2H4O2. And again, when writing molecular formula, we simply total up how many of different types of each of the different atoms that make up the molecule. Here in this case, we see the 2 carbon, 4 hydrogen, and 2 oxygen. Thus, the molecular formula of the molecule is as follows: C2H4O2. Now, the empirical formula of this molecule will then be CH2O or O1 or C1H2O1. And the reason why is because the empirical formula shows the lowest ratio of the different elements. So here in this case, the ratio between carbon to hydrogen to oxygen is 2 to 4 to 2, which we can further reduce this to 1 to 2 to 1. And therefore we have our empirical formula. Now, if we are given the molecular formula or the empirical formula of a substance, we don't know what is its exact chemical substance or chemical identity because we do not know how the atoms are connected together. And that is the concept of the word isomer. Isomers are basically molecules with the same molecular formula, but a difference in how the atoms are connected together. So for an example, these are 2 molecules right here that we will call them isomer. So the reason why we call them isomer is again, iso means the same. And here in this case, same molecular formula. So if we were to be given the chemical formula of this molecule, if we were to add all of this up, this is C2H6O1. And for this molecule, this is also C2H6O1. So these 2 substances have similar chemical formula, and therefore we call them isomer of each other, but they are different molecules. So isomer are actually different molecules, but the only thing that make them the same will be the same chemical formula. And the reason why they are different chemical substances is because of the connectivity of the atom. Here, in this case right here, we see the oxygen is not between the 2 carbon, whereas in this molecule, the oxygen is in the middle of these 2 carbon. And if we were to add all of the atoms up, we would then see they have these types of chemical formula. So have same chemical formula, but a different molecule. So therefore, we call them isomers. So if we were simply give you a chemical formula of a substance, we wouldn't be able to figure out whether we have this molecule or this molecule over here. So therefore, the molecular formula of a substance do not tell us the exact chemical identity. But if we were to be given the structure formula, here in this case, the Lewis structure, it is now possible for us to distinguish between these 2 molecules. The molecule on the left is ethanol, and the molecule on the right is called methyl ether. These are organic molecules that we will learn how to name later when you take organic chemistry. And another way to represent the chemical formula of a substance is by using molecular model. So molecular model is a more accurate and more complete way of specifying a molecule. And in a molecular formula, it shows the connectivity of the atom. Connectivity of atoms. And it also tells us the types of bonds that are present as well. And furthermore, it also tells us the 3D structure of a molecule. So molecular model is a very accurate way of specifying the structure and providing a lot of information about chemical substances. And the bars in the molecular model are typically color-coded following this order below. Hydrogen will be white, carbon is black, oxygen is red, blue is nitrogen, and so on. And here are examples of some of the types of molecular model. So here in this case, this is a molecular model right here, and we call this the ball and stick model. Versus this one right here, is called the Space-Filling model. Both of these are molecular model, and they should show the 3D structure of the molecule. Also, what kind of atoms that make up the molecule. So here in this case, we know this is a hydrogen, and in the middle there is a carbon based on this color coding that we have seen above. And throughout this class, and maybe in more chemistry classes, we will learn to use this different molecular model.